Hello everyone, I'm Dr. Shariful Halim, and today we are going to discuss about normal distribution and confidence interval. So let's just start with the measures of central tendency. So measures of central tendency are actually three, which are mean, median, and the mode. So mean is simply the average of values in a dataset. So we can calculate the mean by adding up the sum of values and dividing it by the total number of values. And mean are the part of central tendency which are most affected by the extreme values, which are also called outliers. Next we have the median. Median is the middle value of a list of data sorted from least to greatest. Suppose we have a data set like 1, 2, 3, and here the 2 is the median. Next, if there is an even number of values, the median will be the average of the middle two values. Suppose we have a data set like 1, 2, 3, and 4, and it's the even number of values, so the data set has two middle values, so 3 and 2, so the median will be 3 plus 2 divided by 2. Median is also called the 50th percentile value. Next we have the mode. Mode is the most common value which is least affected by the extreme values or outliers. This is very important to note. So now we can solve the question by using the concept that we got from the previous slide. A patient in the ICU has 20 serial measurements of pulmonary capillary wedge pressure taken over 2 hours. The maximum recorded value is 12 and the minimum recorded value is 10 mm mercury. If the next measurement is 26 mm mercury, which of the following is most likely to remain unchanged? So I think that's a very good question. You can pause and you can solve it by yourself. Now I am solving it myself. So here we can see in the most of the measurements, like 20 measurements showed a range of pulmonary capillary wedge pressure from 10 millimeters to 12 millimeters mercury. But in one measurement you have a very extreme value which is 26 millimeters mercury, and this extreme value is called an outlier, and this outlier actually least affects the mode. So here the mode will be the value which will be least affected and which will be most likely to remain unchanged when you get an extreme value like 26 or an outlier like 26. So I think that solves the question. Now we have the measures of dispersion, and there are actually two important measures of dispersion. One is standard deviation and another is standard error of the mean. So standard deviation is the deviation or variability between the mean, variability that exists from the mean in a set of values, or in a better way, standard deviation is actually the average distance of observations from their mean. And standard error of the mean is an estimate of how much variability exists between the sample mean and the true population mean. And if the standard deviation is sigma and n is sample size, the standard error of mean should be standard deviation divided by root over of n, or sigma by root over n. So you can see standard error of mean have an inverse relationship with the number of population or sample size. So standard error of mean actually decreases if we increase the number of sample in our population or number of sample in our test. And that's pretty easy to understand, because standard error of mean is actually a measurement of how good or how well representative of the test sample of how well representative the test sample is in relation with the normal people or the population, the real population. So whenever we have a high number of sample, it would be as close as the real situation, so it would actually decrease the standard error of mean. So standard error of mean is actually an estimate of the quality of the sample that we are testing. And here we have a very important concept which is called normal distribution. So this is a theoretical situation in which the mean, median, and mode are in the center. In the center of the values, they are all equal and they are in the center of the values, and the population is distributed equally in both of the sides, in lower side and also in the upper side. And this is a this creates a bell-shaped graph, and also called a Gaussian distribution. And this bell-shaped graph, from that we can actually predict how much value or what percentage of value will lie in which range. So as you can see here, this is the middle portion, which is the mean, median, mode, and from the mean, when we go one standard deviation up and one standard deviation down, we have now a range. So from -1 standard deviation to +1 standard deviation. So this range will actually include 68% of the population. And now we have another range, which is -2 standard deviation to +2 standard deviation. So this population will include 95% of the people. And from -3 standard deviation to +3 standard deviation, this population will include 99.7% of the people. And normal distribution is also called Gaussian distribution, which is a bell-shaped curve. Theoretical, mean, median, mode are equal, and the peak is called modal peak. So here we can use the concept of normal distribution to solve the question. So a large study of serum folate in women aged 16 to 45 years revealed that this parameter is normally distributed. So it has a Gaussian distribution or a bell-shaped distribution. And here the mean is 5 nanogram per ml with a standard deviation of 0.5 nanogram per ml. According to the study results, 95% of the serum folate observations in those patients will lie between the following limits. So we can actually use those information and we can apply those information in this graph, in this specific graph. So here the mean is 5 and it says that 95% of the population should lie, and it asks about what is the range in which 95% of the population will lie. So as you can see from this graph, 95% of the population actually lies from -2 standard deviation to +2 standard deviation. So we have to actually calculate both of the ranges, upper range and lower range. So as the mean is 5 and standard deviation is 0.5, so 2 standard deviation should be 1. So 2 standard deviation up from 5 is 5 plus 1, which is 6, and 2 standard deviation down from 5, which is again 0.5 into 2, which is 1, and if we subtract 1 from 5, it will be 4. So from 4 nanogram per milliliter to 6 nanogram per milliliter is actually from -2 standard deviation to +2 standard deviation. So this will be the range 4 to 6, which will include the 95% of the population. So it solves our question. The answer will be from 4 to 6 nanogram per ml. We have another question here. So here we have a study population of 400 and they are hospitalized with diabetes mellitus related complications, and it shows that serum cholesterol level is normally distributed, variable, with a mean of 220 mg per dl and a standard deviation of 10 mg per dl. Based on the study results, how many patients do you expect to have serum cholesterol more than 240 mg per dl in this study? So let's use these study informations to our graph again. So here the mean is 220 and the standard deviation is 10. So SD is equals to 10. So one standard deviation up will be 230 and 2 standard deviation up will be 240, and again 1 standard deviation down will be 210 and 2 standard deviation down will be 200. So the people who have a cholesterol of 200 up to the people who have a cholesterol of 240 will be the 95% of the people in this study group. So 95% of the people in this study group have a value, cholesterol value ranging from 200 to 240. And now we have to calculate what percentage actually have more than that. So actually 5% of the people does not fall in this range. So 5% among those 5% of the people, some of them which is 2.5% of those people have a value lower than 200, and 2.5% of the people have a value more than 240. So actually we have our percentage, so there will be 2.5% of the population in the study group who will have a cholesterol level more than 240, and as the study population is 400, what we have to do, we have to actually multiply 400 into 2.5 divided by 100, so it will actually come out as 4 into 2.5, so it will be 10. So there will be, the answer will be 10. So there will be 10 people who have a cholesterol value more than 240 milligram per dl in this specific study population. So here I have a picture actually to show you what I have shown in the previous slide. So here 95% of the population actually lies between minus 2 SD up to plus 2 SD, and actually 5% of the population lies outside of this study range. Among those 5%, 2.5% of this population lies below minus 2 SD, and another 2.5% is staying above plus 2 SD. So that should clear your concept. Now let's talk about the confidence interval. So actually the mean of a sample is only an estimate, and the confidence interval specifies the high and low limits between which a given percentage of the population would be expected to fall, meaning interval in which the true population mean lies. So confidence interval is calculated by this equation. So confidence interval is equal to mean plus minus z-score multiplied by standard error of the mean. And as you know, the standard error of mean is equals to standard deviation divided by root over n. And the 95% confidence interval is actually corresponds to a p-value of 0.05%. Very important to note. And it is actually the most commonly used value in medical research. And for the 95% of confidence interval, z-score is actually taken at a point of 1.96 or simply 2. So 95% confidence interval is equals to mean plus minus 1.96 multiplied by standard deviation divided by root over number of the population. For 99% confidence interval, z-score is taken at 2.58 or simply 2.5, and for the 99.7% confidence interval, z-score is 3. And let's solve the question by using this concept. A researcher is interested in the blood folate level of women who live in a population with high incidence of neural tube defects. He takes a random sample of women aged 18 to 45 and measures their blood folate levels. He reports the mean, the standard deviation, and the variance. He also states that he is 95% confident that the population mean of the blood folate level lies somewhere between 2.4 to 4.6 nanogram per milliliters. The last statement is based on which of the following calculations? So here actually the question is asking for the relationship between the confidence interval, which is 95% confidence interval, and how we can calculate it. So we can actually get the 95% confidence interval by this calculation, which is the A. So 95% confidence interval should be calculated as mean plus minus 1.96, which is the z-score, into standard deviation divided by root over n. So I think that's a very easy question. So we can actually use confidence interval in different situations. So first use, if the 95% confidence interval for a mean difference between two variables includes 0, then there is actually no significant difference between two groups, and the H0, which is the null hypothesis, is not rejected. So you are actually accepting the null hypothesis, and null hypothesis is always there is no difference between two groups. Another implication is when the 95% of confidence interval for odds ratio or relative risk includes 1, then it should tell you that there is no significant difference between two groups, or H naught or null hypothesis is not rejected, or you are actually accepting, or you are actually staying with the null hypothesis. And null hypothesis is always that it says that there is no relationship between two groups. And now another implication is, if the confidence interval between two groups do not overlap, statistically significant differences should exist. So if confidence interval between two groups do not overlap, there is some statistical significant difference. And if the confidence interval between two groups overlap, it should tell you that there is no significant difference between two groups. So here we can actually see another question which will integrate the concept of confidence interval and p-value. A prospective cohort study was conducted to assess the role of daily alcohol consumption in the occurrence of breast carcinoma. So this is the risk factor and this is the outcome. The investigator reported a 5-year relative risk of 1.4 for people who consume alcohol compared to who do not. The 95% of confidence interval was 1.02 to 1.85. Which of the following p-values most consistent with the result described above? So here we have multiple options. So the most important thing to look here is confidence interval. So here the confidence interval is from 1.02 to 1.85. So the confidence interval is more than 1, and this confidence interval is for relative risk, and the relative risk is in between these values. And whenever you have a confidence interval for relative risk and it is more than 1, it should tell you that there is actually a significant difference between study population and between the two study populations, or between a risk factor and an outcome. So whenever we have a significant statistical value, we actually set the p-value as less than 0.05. So here for 95% confidence interval, and for 95% confidence interval which is more than 1, and there is actually a important relationship or significant relationship between the risk and exposure, the p-value should have been set with lower than 0.05. And here there is one value which is less than 0.015, which is 0.04. So p-value should be 0.04. So I think that's all from me today. Thanks for watching my video.